Hello everyone and welcome to my Information Chaos Theory Revisited presentation where I'm going to delve into data-driven information management. And this presentation is actually quite similar to Dirk's earlier presentation, but it's got a different slant to it. So my name is Emma Hooper and I'm an R&D lead at the Build Data Group Research Institute, which is essentially a think tank for digital built environment. But before that, I was in information management, and before that, I started out as an architectural technician, starting off on the drawing board right through to BIM. So therefore, everything I've learned about information management and BIM has come directly from working at the coalface on projects. And I'm also involved in all of this other stuff. So that includes Vice Chair of Building Smart UK and Ireland and an honorary fellow at the University of Nottingham. So I always start my presentations with this slide and this word information. It's a word we take for granted, a subject which is difficult to understand and something we're completely overwhelmed by on a daily basis. Yet information creates our reality. And for this presentation, I want you to forget about everything you know about BIM, the acronyms, the jargon, the pretty 3D models and the technology, and start to just think about this word. Because for me, this thing we call information is fundamentally key to unlocking digitization. And what I'm going to talk about is underpinned by my favourite subject, information science, which focuses on the principle, structure, quality of information and how it works within a system. And this system could be on a capital works project or managing information with an entire organisation. And viewing information from this angle is what I'm certain will lead to better information management and interoperability within our industry. And as an industry, we need to start viewing information as an important asset in its own right, on par with the physical facility. And this all starts with clients. Clients procure buildings, bridges and roads, but they also procure the information that relates to them. And if that information is received in a way which is useful and there are processes in place to manage it, it can provide great value to organisations. But to do this, information management needs to be given more attention and resources than it does now, and defined at an organisational level before projects and other appointments take place. And for me, because I'm biased, I say it's the one true asset to rule them all. And this all starts with information management. So what is it? Well, information management is about the specification, delivery and governance of just the right amount of information concerning the design, construction, operation and maintenance of buildings and infrastructure. And that's across all information, whether it's structured or unstructured. And to define information management at an asset level, we need to first think about it across an asset's life and its impact on an organisation. And this is both from an activity-based management layer, which people interact with, and secondly, an information layer. And this is the layer which technology mainly interacts with. And hey presto, you have information management. So where does BIM fit into this? Well, BIM, which is very much about managing the structured information within this wider information management framework, with a key aim of making as much of our information as structured as possible. Because when it's structured, we can achieve these outcomes through automation and at a bigger scale. And that's all great, but this is what we have now: a tangled and highly chaotic web of stuff. Incorrect, incomplete and lost information introduces so much risk to projects and organisations, yet for an industry obsessed with risk, it's barely ever thought about. And as we create more data, develop new standards, processes and technology, and form new initiatives, this beast is growing and getting more tangled by the day, and this is what scares me. And why do we have this chaos? Well, it's for many reasons, and some you probably wouldn't even expect. All of them stop us from working to a bigger information management picture. Because when it comes to information, it binds us. We're all in it together. And for this presentation, I'm going to focus on number 5 and the technology first approach. And since the introduction of CAD software, the language, structure and rules of the software have been the ones used in helping to define the information for the asset, which is often poorly considered. Bring this forward to the era of BIM and it's only gotten worse. Software applications are tools which process information. They should never be used to define it. The structure and language of information should be defined outside of software, considering the bigger information management picture, and also be neutral and open. Therefore, information should be defined independently of software applications. I'm not saying technology is bad, of course it's not, but it needs to fit into the natural flow of information and not try to change it for its own benefit. So let's get back to information management and those two layers. So if we overlay some of the main standards, the ISO 19650 series is generally for the management side. And if I could summarize what takes place in this layer, it would be this process, which operates on cycles, and it's appointment based, so it's not based on work stages. So for each appointment, we specify what information is needed, then we select the right suppliers to deliver it, which goes into contracts. Next, the suppliers plan the delivery and deliver the information where it is stored against the original requirements and hosted within a store. The information is then presented or visualized for reporting purposes and used by day-to-day systems. So it's basically mirroring the creation and maintenance of the information as an asset, but in the virtual world. Then in the depths of the information layer, there are many standards, and this includes the ones shown, but there are many, many more. And within this layer, it is important to understand why standardization is required. So if we revisit what I talked about at the start, focusing on a technology-first approach has created this point-to-point scenario where data has to be transformed as it's passed on. And this was bad enough when there were only a handful of applications. Now we have hundreds, which gives us thousands of potential permutations. And what's more, we're locking information away in a bespoke proprietary language, which always needs an application to access it, which isn't guaranteed. Data needs to live at least as long as the physical asset, and there needs to be a long-term sustainable solution to this exchange problem. And because currently, even at one simple exchange, we can have problems getting the right data out of one system and then to another. And as an industry, we have massive problems with interoperability. And as a result, we struggle to get our systems to work together. And this just isn't in the design stages, but throughout a facility's life. So what's the answer? Well, we put the information first, so it's a software which serves the information and not the other way around. We open up the information, so we're not limiting which software applications can plug in, and we use a standard approach, so the data doesn't require so much transforming. So rather than this point-to-point scenario, we get this: a baseline information layer which spans an asset's life, containing all the structures, rules, and language. And as I've said, to enable information to be shared, this needs to be standardized. Therefore, we need to add to this statement. And it's this standardized approach that really helps us to start to untangle that mess that we saw earlier. And if we have standardization, this enables the receiving platform to know where to look for the data it needs and what the relationships are, so it too can make sense of it. And this allows us to automate tasks such as checking, analyzing large data sets, and to carry out predictions. The information within the information layer is complex. There's no getting around that. It's structured, unstructured, multifaceted, multidimensional, connected in many ways, and the view of it changes according to its use. Standardizing this is key to increasing interoperability, and to give us any chance of joining this up, we need to start thinking about schemas and data models. And as shown earlier, there are several standards that occupy this layer. However, taking center stage, we need an object-based schema and data model. And we have one in the industry already, and it's ISO 16739, or Industry Foundation Classes, or IFC, which provides the object structure in the information layer. And this is managed by Building Smart International, a non-for-profit organisation. And what's more, it's already commonly used within construction and implemented in many software solutions. And I come across a lot of misunderstanding and misinformation about IFC, so my mission is to help clear that up and explain what it really is. In basic terms, it sets out how objects are ordered and how they relate to each other. Humans see buildings and infrastructure as physical things, bricks and mortar. A computer, though, needs to be able to understand what it is in a computer language. And that's what IFC is. It's a digital representation of a built facility. And the IFC schemas can be found here for free on the Building Smart website. At its core is an object-based data model, which provides the rules to give everything a unique place and to connect it all up. It contains three important parts: entities, attributes, all linked by relationships. And these entities can cover anything from a door, a system, a whole facility, a task, and some even represent geometry. And then there are some entities which allow us to connect to the outside world. So we can link documentation to objects, therefore very importantly connecting unstructured and structured information. We can link to external databases which will contain their own data models and dictionaries, so for things like product manufacturers' data, and we can add classifications to give it a local language. IFC allows us to digitally represent this. So an instance of a pump is associated with space and a pump type. The space is located on a building story and may be part of a zone. The story is part of a facility and that sits on a site. The pump will be part of a system and be connected to pipe fittings. It will have detailed classification assigned to it and be referenced in documents. It will have basic information like name, description, and ID, and properties like pressure. It might also have risk associated to it. And what does it look like? Well, I'm not going to even attempt to describe that in a computer language, so here's a picture. Connecting all of this up is what IFC allows us to do, and there's nothing else in the built environment which can do it at this scale. And from this, you can see it's the relationships which make IFC so powerful, and we need to start thinking of them as being just as important as the entities or objects. People describe IFC as a classification system or a data dictionary. It kind of contains elements of these things, but predominantly it's a framework of connections. Therefore, going back to this example, it's the arrows that are the most important part. And if we're doing IFC right, it should be hidden in the background, minding its own business and doing its job connecting data throughout an asset's life. And most people should only see how the data is visualized or presented as information. And this can be tables, data sheets, 3D models, even construction drawings and text documents. The important part is to structure the data in accordance with the IFC schema, and it can be used and displayed in so many ways. But it's important to understand that IFC doesn't have to be visualized like this, and it doesn't even need to contain any geometrical information. An IFC is not just for describing boilers and walls, but it's capable of describing all of this, from sensor data for smart buildings, to construction programming, to work orders, to materials. It tries to be all-encompassing, but we're not even scratching the surface of it yet. It's currently based on the Express schema, and this is what a tiny part of the IFC data model looks like. And to most, this will just look like gobbledygook, and that's fine, because it's a computer that needs to read it, not people, and this operates in the back end of software. And then in future versions, such as ISC5, which is currently being developed, they are looking at moving away from Express to UML. This is a building or infrastructure facility turned into pure logic. And for me, it's one of the best achievements in recent years in the built environment. Imagine in the early 90s coming up with an idea for a standard data model for the built environment when we were barely using CAD or even the internet. For IFC, there are several exchange formats. The main one we exchange is a step physical format, which is text-based. And because it confusingly has the .ifc file extension, this has caused a big misunderstanding that many think IFC is just a file format and not an entire data model and schema. And then there's also XML, and then there's another 3 in development for linked data. So there we are. We have both of our layers, and for effective information management, you cannot have one layer without the other. And bringing them together, it becomes clear that all those activities in the management layer are around specifying, building up, updating, and maintaining connected information across the life of an asset using standardized schemas like IFC. So let's explore this further. The connected information I've just described is in fact the information models from ISO 19650, but this is where we always go wrong and where I would love to start to change people's perceptions. There is a world outside of Revit and other mainstream authoring tools. In fact, when considering the bigger picture, they are small parts of the puzzle. Revit doesn't connect information in the way we need it to for representing everything to do with the facility. It's for designing, that's its superpower. But there are many other information sources that need to be added. The information model has to exist on its own merits, so any data, no matter where it's from, can plug into it. So what do I mean by information models? I mean this: a truly connected information model of entities and relationships which connects data, geometry, and documentation within a database. So you can select something and you know who created it and when and what it's connected to. And this sounds very familiar. Oh, because it's the same as this, which is basically this. An information model we can query explicitly or implicitly. Basically, we query the heck out of it. And this is everything we're striving towards with regards to information management, a true digital representation of the physical facility. And once I started to think like this, all the standards became so much clearer. So what IFC can be, and you may have spotted this, is a standardized structure for an information model, which is in fact the core of a CDE. So it's much more than a file exchange between, say, Revit and Tekla. So rather than having CDs as they currently are as document management systems, we start to release the trapped data from the files and put it directly into the CD database, where we connect it with any remaining documentation so we can find, share, query, etc., but not using files but discrete data. And the word information container was purposely used in ISO 19650 rather than file to set us up for this type of working. So let's think about it in the context of a built asset. So this starts with a new build project in the physical world, and although in the physical world the actual build part is a long way off, in the virtual world the model is started from the very outset. At the point we might know the location of the site, the area, and what the name of the project and facility and site is. So this is a very small model. The small model, together with information requirements, is passed to the designers where they create the base object structure using their authoring tools to design and analysis tools to refine. So the model starts to take shape. And the client will probably need parts during a project to satisfy different purposes and at certain points of the project where it will need to be checked. So next, let's build the physical facility. And for this, we'll have new information which enriches the base information that the designers produced. So things like warranty, commissioning, and installation information, including the evidence documentation. But this is where we have issues, because currently we only write the information model through the design authoring tools. So we end up going backwards and asking the designers to add data they're not responsible for. We need a way of writing to the model by enriching what is already there. So what happens next? Well, for final handover, the project information model is issued to the client, where the required information is extracted and merged into their asset information model, which is a database of all the information they need for their purposes. But it doesn't stay still, as it's constantly changing as trigger events occur on the physical build, many at the same time. So for example, a pump breaks down, so now what? Well, the pump information from the model is made available to the maintenance engineer together with information requirements. And in the real world, they replace the pump. So in the virtual world, they update the information which has changed. So it could be the manufacturer, the model number, and the warranty. And this could all be done by simply filling in a form. It gets checked and it's merged back in. So it's not changing the entire model, it's just changing a few bits, a delta approach. And as this is the current state of the facility, the data can be visualized for reporting and used in other enterprise systems. And if it's bidirectionally linked to the physical facility, well, then you've got the start of a digital twin. And at the end of the life, if objects are to be used in other facilities, that object and its data could potentially transfer into another asset information model, contributing to that circular economy approach. So basically, as that object-based specification, IFC potentially could be used, so all processes use the same consistent information layer throughout, a common data model, from specifying information requirements to in use to, very importantly, checking. And the more we can control and standardize the information layer, the more we can automate stuff. And this makes exchanging machine-readable information so much more efficient. It's one structure throughout, and this provides the interoperability and certainty we really need as an industry. IFC isn't perfect, but I believe if we all work together, with one common cause, we can really truly make it amazing. So everything we're doing in information management is fundamentally about information models. We're just not doing it properly yet. Then looking at this from a simplified process point of view, we get this. So purpose drives the appointing parties requirements, which are used in selection and then merged with the lead appointed parties. And this provides the base data set for the information delivery plan, which is then which the delivered information is then compared back against. So this is a process basically from ISO 19650, but looking at it from a data-driven approach. And with it, I believe that there are these three schemas. So there is one for information requirements, which is at a type level. And then this is extended for information delivery planning with more of a focus on the aspect of time and more granular decomposition. And then our delivered information models. So this is the type of thinking that I'm currently working on. So just to wrap up, this, this isn't about blingy software. It's about the information and it's fundamental to everything that we're doing. And for me, this starts to pave the way for knowledge representation and a future of linked data, where every building and infrastructure facility is a knowledge graph. And this is the stuff that really excites me. So there we go.